Let's take a first look at the concept of entropy. We're going to have a lot more to say about this concept later on in the course. The concept of entropy was first developed by Clausius in conjunction with his study of heat engines. A heat engine works in the following way. If I input energy as heat to a piston containing some gas, the gas will expand, and in doing so, it will lift the piston and thereby do work on the surroundings. Now I can use that work to do useful things like drive my car, or move a big weight, something useful to me. Unfortunately, it turns out that in addition to getting work out of this system, there's always some heat that escapes to the surroundings. If I want to measure how efficient my engine is, I need to look at the amount of energy that I've input to my system and compare that to the amount of work I get out of my system. If these two things are equal, I would have 100% efficiency in my engine. That is, all of the energy that I input has become work, has been used to do useful work. Unfortunately, what we find is that the amount of energy input into the system is divided between useful work that I get out of the system and heat that is lost to the surroundings. Since not all of the energy that I put into the system is used to do useful work, my efficiency is less than 100%. When investigating the efficiency of heat engines, Clausius found that the heat lost to the surroundings was proportional to the temperature at which the engine was running. Because the heat loss was greater at higher temperatures, Clausius reasoned that there must be some quantity which is equal to the heat lost divided by the temperature. Clausius called this the entropy change in the surroundings. Notice that the heat lost to the surroundings defines the amount of energy unavailable to do work. Thus, fundamentally, the entropy is a measure of the amount of energy unavailable to do work. Because each revolution of the motor returns the piston, and thus the system, to the same state, the total change in entropy of the system is 0 for each revolution of the motor. However, each revolution results in the loss of some energy as heat to the surroundings, thus increasing the entropy of the surroundings. Hence, we can say that delta S total is always greater than or equal to 0. This is what you know as the second law of thermodynamics.